Alright, I'm going to go back to this series n equals 0 to infinity x to the n. Just this basic power series. If you expand it, then you get x to the 0, which is 1, plus x to the first, plus x squared, plus x to the third, plus forever. Alright, remember x is a variable. X can be any number in the whole wide world, which makes you think that this might look like a geometric series. If you start putting numbers in here for x, then this becomes a geometric series. And you know that a geometric series converges when the absolute value of that number r is less than 1, because this is your r, this is your common ratio. So it will converge when that number is less than 1. And when this number is less than 1, it has a sum. And the sum can be calculated as the first term over 1 minus the common ratio, and the common ratio is whatever you let x be. Right, it should sound familiar. So we are going to take this series, which can be written as 1 over 1 minus x, and we are going to use this to write functions as a power series, because what this means is that this function, 1 over 1 minus x, is the power series from n equals 0 to infinity of x to the n. And this is going to be the basis for everything we're doing in this section, knowing this definition right here. Alright, so what we're going to do is we are going to take functions like 1 over 1 plus x squared using what I just wrote down, and let me write it on this sheet of paper, using this fact. That 1 over 1 minus x is equal to the power series from n equals 0 to infinity of x to the n. Using this fact, we are going to write this as a power series. What we're going to do is we're going to manipulate this to look like this. So what I need is I need a subtraction sign on the bottom. I need 1 on the top. I need 1 here. So I can rewrite this as 1 minus negative x squared. This then is going to replace the x in my formula. And this is the power series from n equals 0 to infinity. All of this is replacing this x. This is negative x squared to the nth power. Simplifying a little bit, this is the power series from n equals 0 to infinity of negative 1 to the nth power times x to the 2n. You multiply those exponents. And this is the power series for our original function, which was 1 over 1 plus x squared. Okay? See what I did? I took this, I manipulated it so I could substitute into what I know. Right, here's another one. F of x equal to 1 over x plus 2. Well, somehow I've got to get it in the form 1 over 1 minus x. That's what I need it to look like. So I would rewrite this. First of all, change this, put to the order, so I have the constant first. Then I've got to get a 1 right here. So I'm going to have to factor out a 2 in the denominator. So when I factor out a 2 from this, I have 1. Plus, I've got to factor a 2 from the x, so that means I write x over 2. Because I have to have a 1 down here. This is what my formula looks like. So this is 1/2 going to pull this 1/2 out in front, times 1 over 1, I need this plus to be a minus, minus negative x over 2. And now this part is in the correct form. This is what will go in my formula for the x. So this is 1/2 the sum from n equals 0 to infinity. Negative x over 2 replaces the x in the formula to the nth power. Is everybody following what I'm doing? Question? This is not simplified enough. I need to pull this 2 into my summation. So this is n equals 0 to infinity. This negative x to the n is the same thing as negative 1 to the n, x to the n, over. This is 2 to the nth power times 2, which gives me 2 to the n plus 1 power. And this is the power series for 1 over x plus 2. Everybody understand about pulling the 2 in? This is 2 to the nth power times 2, which is 2 to the n plus 1. You add your exponents. Question? Okay, here's another one. I have 4x over 1 minus 3x squared. Alright, so what I need for this one, I need a 1 on the top. So I'm going to factor the 4x off of the top. So I have 1 over here. And I need 1 minus something. Well, I've got 1 minus something. So this is in the correct form in the brackets. So the 4x goes outside. And this as a power series is from n equals 0 to infinity. This 3x squared is what replaces the n. Now you need to bring this 4x to the inside of your summation symbol. So this is the sum from n equals 0 to infinity. I'm bringing the 4 in. This is 3 to the nth power. And this is x to the 2n power, but I have times this x that I'm bringing in, so when I bring this in, that's going to be 2n plus 1. And it's at n equals 0. Question? All right, I noticed in WebAssign, they tell you the starting point. They put this part of the problem there for you, and you have to fill in the rest. In every one of these start at 0, which is fine, but they may change it and they may put a 1 here. And I'm going to do one in a minute where we're going to have to shift our starting point to match what we have to put in the computer. Okay, so pay attention to what they write right here on your problems. Right here. All right, this x, when you bring that in, you've got times x, so you add the exponents. Okay? All right, another thing on WebAssign is they're asking you for the interval of convergence or maybe the radius of convergence. I am not going to ask you that for these problems. Right now, all I want you to concentrate on is writing the function as a power series. So everywhere it's got a blank for you to write the interval of convergence, that's going to count 0 points. So you'll probably have a red X beside it if you leave it blank, but it will not count against you. Does that make sense? You're only getting the points for this right here. So you can leave this blank. But you would do this the same way you would do it in any time before you do the ratio test and look at the absolute value. All right, here's another one. I have 1 minus x over x plus 2. For this one, I'm going to split this into 2 fractions and work it as 1 over x plus 2 minus x over x plus 2, because I can write a power series for each of these. So 1 over x plus 2, I would change that to 2 minus negative x. I'm going to factor out this 2. When you factor the 2, remember you've got to put it under your x. You've got to factor it out from your x. So this is 1/2 times this. The power series for this is 1/2 times the sum from n equals 0 to infinity, negative x over 2 to the nth. When you bring your 2 in, you have n equals 0 to infinity, negative 1 to the nth, x to the nth, divided by 2 to the n plus 1, because you've got 2 to the n and you've got this 2. So that's half of the problem. Now go over here and do this one. I've got minus x over x plus 2. So you're pulling out the x, and then you're going to have the exact same thing right here. This is going to be 2, 1 minus negative x over 2. It's the same exact thing. And when it comes down here, this is x times the sum, x over 2, sum from n, should be a subtraction sign, n equals 0 to infinity, negative x over 2 to the nth. And when I bring everything in, negative 1 to the n, x to the n plus 1 over 2 to the n plus 1. So I have this series minus this series. Alright, everybody follow that? Alright, the one that you have that's like this on your homework, I believe it's either problem 5 or problem 6. They do not want the answer like this. In fact, what they do is they have a constant plus, they have a constant, a number, plus the sum from n equal 1 to infinity, and then they've got a blank. They wanted these two combined, but they want them to both start at 1, is what they did. Now, let me see if I can make it work on this particular problem. All right, to see what they did, or what you're going to have to do on your homework problem to get the answer written. First of all, we're going to try it on this one. I haven't tried it to see if it'll work, but hopefully it will. What you do on your problem is you take this first series right here and you evaluate it when n is equal to 0. When n is 0, this becomes positive 1, this becomes 1, and 2 to the first power. That becomes the number 1/2. Plus the rest of the series. Now it's going to start at 1. The rest of it is negative 1 to the n, x to the n, over 2 to the n plus 1. So I took the first term of this series, 1/2. The rest of it starts at 1. Then what they did to this series is they shifted the starting point on this one. What they want to do is they want to get this x to match this x. So you can add them together. So if this x and this x match, then you can get a common denominator and add them together. So they're going to shift the starting point from this one to n is equal to 1. That means we're going to substitute everywhere we have an n, we're going to put n minus 1. Because if you solve that, you get n is equal to 1. So you substitute n minus 1 here, you substitute n minus 1 here, you substitute n minus 1 here, and see what happens. Yes, you can do it. Quit making those eyes. So we have minus the sum from n equals 1 to infinity. This is negative 1 to the n minus 1 power. X to the n. Our n minus 1 plus 1 is 2 to the n. If that's n minus 1, I move the 1 over there, I have n is equal to 1. N becomes n minus 1. This becomes x to the nth power, and this becomes 2 to the nth power. So now I have 1/2 plus these two series. They both start at 1. So we get our constant that goes right here.
So that's the only way you can get the constant. If you use 0, and then the next you can do the n minus 1 equals 0.
Right, because you're trying to make these things match. So I'm going to do it by shifting the starting point of both of these series. I did it 2 different ways. I shifted the starting point of this one by evaluating the first term. I shifted the starting point of this one by changing n to n minus 1.
Well, we have anything other than n equals 1? Will there be some other ranges?
I can't think of any. There may be an n equal 2 or an n equal 3.
So you can still evaluate the first one for 0, then you just do n minus 2 or n minus 3?
Yes.
Okay.
You just shift it to make it look like what they want for your answer. All right, now this minus sign, I'm going to take this minus. This is like a negative 1. If I bring this negative 1 and this here with this negative 1, what happens with that? No, they don't cancel. This is negative 1 times, this is another negative 1. You add the exponents. This becomes negative 1 to the nth power, which is the same thing that I've got right there. So this is negative 1 to the n, negative 1 to the n, x to the n. I'm just going to write it. Okay, to add these two things together, I need the same denominator. All right, your problem does not make you get that. And they would probably accept this, but they want it as one series. Okay, and that's what we've done. We've got one series, and these would add together if the denominators added together. And these denominators are a little bit different. We could do some more algebra and pull it out, but I think we'll just stop here. But what I want to show you is shifting your starting points. Okay? And this is how they're going to get their constant in the front. And when you get to your point right here, I don't think you're going to have denominators. You're going to be able to just add this without any issue. All right, do you have a question? Okay. Now that you've got functions written as power series, you can take the derivative of a function and you can integrate a power series because it's nothing more than a function. So if your function is written, here's a power series right here. F of x is c sub 0, c sub 1 times x minus a plus c sub 2 times x minus a squared plus it equals 0 to infinity, c sub n times x minus a to the n. This is a function. You can take the derivative of this function. if I take the derivative of this, f prime of x, what is the derivative of a constant? 0. The derivative of this next term is c sub 1, because that's x to the first. The derivative of the next term is 2c sub 2 times x minus a. The derivative of the next term is going to be 3c sub 3 x minus a squared. We're taking the derivative of each term, plus, when you get out here, you took the derivative, you actually lost a term. You see this c sub 1? This series now starts at 1 to infinity. And the derivative of this is n c sub n x minus a to the n minus 1. You take a derivative of the power series, you can take it term by term, or you can take the derivative of this series right here. When you take a derivative, you lose a term. You can integrate a power series with respect to x. If you integrate the c sub 0, you get c sub 0 times x minus a. Plus, if you integrate this one, you get c sub 1 times x minus a, squared over 2. Plus, integrate this, c sub 2 times x minus a to the third over 3. Plus, somewhere around here, I've got to have plus a constant c. When you integrate, you always get your constant c. So this is the sum from n equals 0 to infinity of c sub n x minus a to the n plus 1 divided by n plus 1 plus a constant c. So you can integrate term by term, or you can integrate this whole thing. You are going to use this to write different forms of your power series. What is it, Will? You got a question? Okay. All right, here's some problems that you're going to have to either take a derivative or integrate in order to write these as a power series. All right, here you've got f of x is equal to 1 minus x quantity squared. All right, this does not look like the other terms because my whole denominator is squared. So in order to get this, let me look at this function. I happen to know that the derivative of this will look similar to this. So let me look at the derivative of this function right here. The derivative of this is the bottom times the derivative of the top minus top times the derivative of the bottom divided by the denominator squared, which is 1 over 1 minus x squared. I took my original function. I knew that the derivative would give me something like this. As a matter of fact, the derivative of this gave me this exact function, which means if I want to find a power series for this, all I have to do is whatever I did to this. I took the derivative to get to this. So once I know the power series for this, which is this one, all I have to do to get the power series for this one is take the derivative of this. So taking the derivative of this power series with respect to x That is the series from n equals 1. When you take a derivative, you lose a term, n equal 1 to infinity of n x to the n. And that is my power series for 1 over 1 over 1 minus x squared. Question? All right, look at the natural log of 3 minus x. This is what you're using. This is the basis for everything we are doing. Okay? This does not look like that. But I know that if I take the derivative of this, again, it's going to look similar to this. So let me show you what the derivative looks like. The derivative with respect to x of the natural log of 3 minus x is 1 over 3 minus x times the derivative of the inside, which is negative 1. The derivative of this is 1 over 3 minus x. I know how to write this as a power series. So what I'm going to do is I'm going to take this, negative 1 over 3 minus x, and I'm going to write that as a power series using what I know. So I'm going to factor out the negative 1/3. So I have 1 over 1 minus x over 3 as a power series. This is negative 1/3 times the sum from n equals 0 to infinity, x over 3 to the nth power. Simplify this. I'm going to leave the negative outside. N equals 0 to infinity, x to the n over 3 to the n plus 1. And this is the power series for negative 1 over 3 minus x. This is where I am. Did everybody follow me to this point? But this, I know the power series for this, but this is not what I want. I want the power series for the natural log, not the power series for this function. So think about it. How can I get from this function back to the natural log? I already took a derivative. I took a derivative of this to get to here, so what I do to get back is integrate. So to get back to a natural log, I need to integrate this with respect to x, which means I integrate this side with respect to x. The integral of this has got to be the natural log of 3 minus x, because the integral undoes it. It's the opposite of the derivative. Equals. I'm going to integrate this side over here. When I integrate this, I have negative n equals 0 to infinity. You are integrating the x with respect to x. This is basic integration. So this becomes x to the n plus 1 divided by n plus 1 times 3 to the n plus 1 plus your constant c. Are you with me to this point? I am not finished with this problem. I am not finished with this problem because I've got this constant c hanging around, and I don't have a constant c hanging around in my problem up here, so I have to take care of it. I have to find out what c is. To find c, let x be 0 in this equation, because that will help me solve for c. If let x be 0, I have the natural log of 3 is equal to. If x is 0 right here, then this whole fraction is 0, and I'm left with c. So c is the natural log of 3. So my power series for the natural log of 3 minus x is the natural log of 3 minus this sum. This whole thing is the power series for this. On your homework problems on WebAssign, I think they are going to find your constant for you right here, and then you have to write this. But then I also think they do not like this 0 starting point with all these n plus 1s. I do believe they are going to change your starting point. So you pay attention to what they have put on WebAssign. If this is a 1, then you've got to shift every one of these so that they reflect that. Do you need me to shift this one to n equal 1? I'm going to put n minus 1, n minus 1, n minus 1, n minus 1. So it's going to shift. It's actually going to be n equal 1 to infinity, x to the n over n, 3 to the n is what it would actually be. So I would accept this n equals 0. It's fine with me. They don't want that. They want n equal 1. So you shift it the way they want it. Okay. I'd be glad to come back and work another one of these in a minute. But the reason we're doing all this is so we can integrate as functions as power series. Again, there are some functions that do not integrate easily. Even when you put them in your calculator, they'll spit them back at you. So you have to change them to a power series in order to do the integration. So if you are asked to integrate this as a power series, that means you need to take this function and change it to a power series. So you've got t over 1 plus t to the third. Manipulate that and get it as a power series. So this is t, 1 over 1 minus negative t to the third, which is t, the sum from n equals 0 to infinity, negative t to the third. Sorry, that's wrong. Negative t to the third, all to the nth power, sorry. Which is, when you bring the t inside, n equals 0 to infinity, negative 1 to the nth, t to the 3n plus 1. This is your power series. This is what you are going to integrate. So you are integrating the sum from n equals 0 to infinity, negative 1 to the n, t to the 3n plus 1 dt. You are integrating with respect to t. Are you with me to this point? All right, this is basic integration. You're integrating the t. So when you integrate, you have the sum from n equals 0 to infinity, negative 1 to the n. You're integrating the t. So you add 1, t to the 3n plus 3, and you divide by 3n plus 3. This is an improper integral, so you have plus c at the end. And you are done. these are the type problems that you're responsible for. What do I need to go back and look at? Usually the ones where you're doing derivatives and integration are the hard ones. Do you have a question? Should I go back over anything?